Hi guys, Dr. Burns here. Let's take a look at section 8.2 where we're going to just practice a little bit more with hypothesis testing and go over the steps again to run a complete hypothesis test. So as a refresher, there were four sort of general steps that we mentioned when you conduct a complete hypothesis test. First was to state your hypotheses. Make sure you state the null and the alternative hypotheses using the population parameter. That's very important that we always use the population when we're talking about the hypotheses. Prepare, so if you need to, check the assumptions for the central limit theorem. Check to see if they gave you a significance level. If they didn't, you can default to 5%. And just make sure you're ready to go to run your hypothesis test. And then compute, so check the p-hat value and put that data into StatCrunch. StatCrunch will give you the p-value associated with your p-hat value, and then based on that p-hat value, make your interpretation. Do you reject or fail to reject the null hypothesis? What does this mean in the context of the data? So an interpretation doesn't just say reject or fail to reject and stop there. The interpretation needs to make sure when you say your interpretation that you say it in terms of the problem itself. So you rejected the null hypothesis. What did that mean in the context of the original research question? So what are the conditions you need to check? The central limit theorem, of course, still has to apply. So you need to make sure that you are using a random and independent sample, which they usually will tell you if it's a random sample, and SRS would take care of that. A large sample, so how large does it need to be? Large enough for at least 10 successes and 10 failures. So same conditions we used back in chapter 7 when we were talking about confidence intervals, and you would use that p-naught value from your hypotheses to check the number of successes and failures that you would expect. And then finally, a large population. The population needs to be at least 10 times larger than your sample size. A little bit more information here about the p-value. So the calculation of that p-value depends on how the alternative hypothesis is written. If it's a two-sided hypothesis test, so in other words, if it's got not equal to, so if your your alternative hypothesis is p is not equal to p-naught, that's what gives us that two-sided hypothesis test, and the p-value would be the total of the two shaded regions below. Let me give you a little picture here. So if this is your graph, p-naught would go right in the middle. That's what you expect to happen. And then you would have a p-hat value, and it could be on either side. It could either be higher or lower than what you expected. I tell you what, let me write these in terms of z-scores. I think that'll make more sense. Let me do that. So I'm going to pretend we converted everything to z-scores. Remember that z is equal to p-hat minus p-naught divided by your standard error. So that means 0 would go in the middle. That would correspond to p-naught. And then your test statistic, maybe your test statistic is down on this end. You would have a corresponding test statistic on this end if it's a two-sided test. And so the p-value would be the sum of these two regions in the tail. So remember that your p-values are always involving the tails. So your p-value would be the sum of this region plus this region on the other side. Okay? So your p-value would be the sum of those two areas, just like that, if you're dealing with a two-sided test. Now, if it's a one-sided test, let's suppose that we have a left-tailed test to begin with. Your alternative, p is less than p-naught. Then your drawing would look like this. I'm going to put the 0 in the middle again, and then the test statistic, maybe it's down here, but you would shade to the left. It is possible that your graph looks like this, where your test statistic is up here, but either way, if it's less than and it's a left-tailed test, you would still shade to the left. So it would either look like this or like this. So what's shaded would be the p-value. If it's a right-tailed test, so that means p is greater than p-naught, your graph would look like this. You would have maybe your z-score is up here, Or potentially you could have a negative z-score down here, but you would still shade to the right. You would have a very large p-value in that case. So the graph for these is going to look like one of these three drawings, depending on the way your alternative hypothesis is written. And then that p-value, remember, is how we measure our surprise. The p-value, remember, is the probability of getting your particular sample or something more extreme if the null hypothesis is true. And that's what this tells you. For this picture, indicate whether the shaded area could represent a p-value and explain why or why not. So the first picture, what do you say for that? I would say yes, and that would be a two-sided test. So you would have a z-score over here and then a corresponding z-score on the other side. Your sample would have either ended up here or it would have ended up here, but because this is a not equal to for your alternative hypothesis, we need to consider both possibilities. Either it's less than the negative z-score or greater than the positive z-score. How about this one? Could this be a p-value? And the answer is no. And the reason is because the tails are not shaded. This would actually be the opposite. This would be a confidence interval. So remember, a confidence interval is in between a lower bound and an upper bound. And I think that's it. That's all I want to talk about in this video. So tomorrow in class, bring this with you, and we're just going to keep on practicing through the steps for a hypothesis test and making our conclusions. So I'll see you then.